What if I told you that there was a type of shark as big as school buses? Meet Otodus megalodon, the colossal predator that dominated the oceans millions of years ago. From its massive size to its mysterious extinction, Megalodon has fascinated scientists and captured the imagination of people worldwide. But how did this giant shark rise to the top of the food chain, and what led to its downfall? Let's find out. Otodus megalodon, often just called Megalodon, was a giant mackerel shark that roamed the oceans around 23 to 3.6 million years ago, from the early Miocene to the Pliocene epochs. It used to be thought of as a close cousin of the great white shark, but scientists now place it in the extinct Odontidae family, which split from the great white's lineage way back in the early Cretaceous period. Megalodon is often hailed as one of the biggest and baddest predators ever, but we actually only have bits and pieces of it to study, so its exact size and look are still a bit of a mystery. There's some debate over whether it looked like a chunkier version of a great white, a basking shark, or maybe a sand tiger shark. Megalodon likely played a big role in shaping marine life. Fossils show it lived all over the world and probably went after large prey like whales, seals, and sea turtles. Young megalodons stayed in warm coastal waters, munching on fish and small whales. Unlike the great white, which goes for the soft belly of its prey, Megalodon likely used its powerful jaws to smash through the chest and hit the heart and lungs. It had some fierce competition from other big marine predators like Leviathan, macroraptorial sperm whales, and possibly smaller early killer whales. Since Megalodon preferred warmer waters, the cooling of the oceans during the ice ages, along with dropping sea levels and losing nursery areas, might have contributed to its downfall. Additionally, as baleen whales, a key food source for Megalodon, diversified and moved towards polar regions, it left Megalodon with less to eat. Interestingly, Megalodon's extinction aligns with the period when baleen whales started getting much bigger. Megalodon teeth have fascinated people for ages. Ancient cultures in the Americas valued these large, serrated teeth, using them to make tools, jewelry, and ceremonial items. The Panamanian Sitio Conte societies seem to use them mainly for rituals. The Algonquin people mined these teeth from Chesapeake Bay and traded them with the Adena culture in Ohio as early as 430 BC. In the late 17th century, English scientists Robert Hooke, John Ray, and Danish naturalist Niels Steensen, Nicholas Steno, revisited the shark tooth theory. Steno's 1667 report, based on a great white shark dissection, became iconic despite using earlier illustrations by Michel Mercati. Steno also proposed that the megalodon teeth found inland were from ancient marine sediments, uplifted by geological processes. Swiss naturalist Louis Agassiz gave Megalodon its scientific name in his 1833-1843 work on fossil fish. He initially named it Carcharodon megalodon in 1835, but later changed it to Carcharodon megalodon due to its similarity to the great white shark's teeth. Agassiz also mistakenly identified several other species based on megalodon teeth, but these were later considered junior synonyms under the principle of priority. Megalodon's earliest remains date back to the late Oligocene, around 28 million years ago, though there's some debate on this, with some saying it appeared as recently as 16 million years ago. It's widely believed that Megalodon went extinct around 2.6 million years ago at the end of the Pliocene, but a 2019 study suggests it might have actually disappeared earlier, around 3.6 million years ago. Originally classified in the family Lamnidae, genus Carcharodon, due to its dental similarities with the great white shark, Megalodon has since been reclassified into the family Odontidae, genus Otodus. This change reflects the belief that the similarities in teeth are due to convergent evolution rather than close relation. In fact, the great white shark is more closely related to the extinct broad-toothed mako than to Megalodon, sharing a common ancestor about 4 million years ago. Well, if we talk about estimates of the size of the Megalodon has been a bit of a puzzle due to the limited fossil remains available, mainly teeth and vertebrae. Most estimates are based on comparisons with the great white shark, which is considered the best modern analog for Megalodon. Using various methods, researchers have come up with a range of maximum length estimates, from about 47 to 67 feet. A 2015 study, which examined 544 Megalodon teeth from different periods and locations, suggested an average length of around 34 feet. For comparison, large great white sharks usually reach about 20 feet, though some reports claim they can get a bit larger. Megalodon was likely the biggest predatory shark to ever exist, and it's thought that different populations around the world might have varied in size and behavior due to different environmental pressures. An estimate suggests that a Megalodon measuring about 52 feet would have weighed around 48 metric tons. A slightly larger one, at 56 feet, would weigh about 59 metric tons, and the biggest, at 67 feet, could weigh as much as 103 metric tons. In his 2015 book, Donald Prothero suggested body mass estimates for different lengths by comparing vertebral centra to those of the great white shark. This methodology was also used in a 2008 study supporting the maximum mass estimate. In 2020, a team led by Cooper created a 2D model of Megalodon, comparing it to all living lamnid sharks. Their model suggested that a 52-foot Megalodon would have had a head nearly 15 feet long, 4-foot-tall gill slits, a 5-foot-tall dorsal fin, 10-foot-long pectoral fins, and a 12.5-foot-tall tail fin. They followed this up with a 3D model in 2022, estimating the body mass at around 61.56 metric tons for a 52-foot Megalodon. This shark would have needed a whopping 175 calories per day, which is 20 times what an adult great white requires. A 2015 study linked shark size to swimming speed, estimating that Megalodon could swim at about 11 miles per hour, similar to the fin whale. A 2022 follow-up by Cooper and his team calculated an average cruising speed of 3.1 miles per hour for a 52-foot Megalodon, faster than any living lamnid shark, but slower relative to its body length. However, the extinction of the Megalodon was influenced by various changes in Earth's environment and marine life. During its time, the Earth underwent significant shifts, starting with a cooling trend about 35 million years ago in the Oligocene period, leading to the glaciation of the poles. Geological changes, like the closure of the Central American Seaway and alterations in the Tethys Ocean, further cooled the oceans and affected ocean currents and precipitation patterns. These changes likely disrupted major marine ecosystems, negatively impacting the Megalodon's food sources. The Pleo-Pleistocene era saw the largest sea level fluctuations due to expanding polar glaciers, which affected coastal environments and may have played a part in the extinction of Megalodon and other large marine species. Megalodon thrived in warm waters, but as the oceans cooled and suitable shallow warm water nursery sites became restricted, its ability to reproduce was hindered. Nursery areas are crucial for the survival of many shark species as they protect juveniles from predators. Fossil evidence shows that Megalodon was absent from regions where water temperatures had significantly dropped during the Pliocene, suggesting it struggled to maintain enough metabolic heat in colder waters. However, some studies argue that temperature changes didn't directly cause its extinction, as Megalodon could inhabit a wide range of temperatures from 1 to 33 degrees Celsius. Instead, it's likely Megalodon was a mesotherm able to maintain a higher metabolic rate than ectotherms. Megalodon has become a popular subject in fiction, especially in stories about sea monsters. Films and novels often feature this giant shark, keeping its legend alive. The idea of Megalodon surviving into modern times was popularized by Steve Alten's 1997 novel Meg, a Novel of Deep Terror, and its sequels. This led to films like the 2002 direct-to-video Shark Attack 3 Megalodon and the 2018 blockbuster The Meg, based on Alton's book, which grossed over $500 million at the box office. Well, that's it for today. If you enjoyed diving into the world of Megalodon, don't forget to like, subscribe, and hit the notification bell for more prehistoric stories from the depths of history and beyond. Megalodons are for sure gone, but could there be other prehistoric creatures yet to be discovered in the vast, uncharted waters of our world? What other ancient mysteries would you like to explore? Let us know in the comments below.